Well, you've got some time.
The first few pages are the assessment criteria. I highlighted the areas which I thought were important and that I would need to include in my development process. Here we have my set timetable that I made myself and the IDS giant checklist as well. The red areas are questions that I've asked myself to further my development of my product. Here is my initial concept from semester 1. From this I was able to develop my product using this as a basis. I was very happy with how my model came out. I spent a lot of time on it. Using my model as inspiration, I was able to come up with many more designs with all different alterations. The left page was all about seeing if I could make a battery work in my product. I looked at the specific heat capacity and the energy required to make it. I then started ideation for a possible sleeve that goes inside of my design to be able to clean it. I worked out it'd make more sense to have the battery at the bottom so that heat source would rise from the middle upwards instead of on the left or the right, because then it would heat inefficiently. The page on the right was further ideation on whether or not to have a copper ring on or not. By this point my product was starting to become more feasible while I looked at possible clips and ways of fastening the top to the bottom. This page was just possible ideas of how to have a hatch on the side to use as an opening for the food. I then made a second card model. This time the top came off and the battery case, as well as having a small hinge on the top of the lid. I took the model into an IDS lesson to get more inspiration of what I could do next. The idea for the body to collapse occurred, and I started looking at other products that folded in on themselves and come apart again after. I looked at silicone elastomers because I thought they would be an appropriate material for the body. I also developed a hinge for the silicone to go into so that it would be able to be formed and more manufacturability. I then continued ideation of the lid cap as well as how the whole product would go together, looking at internal surfaces as well as how two parts would make, that the plastic and the silicone would potentially be moulded. From this point I realised that some parts would have to be injection moulded. I found a lithium polymer battery pack that would work for my product. It has a 12 volt output and it weighs 85 grams. Using CAD sectional views I was able to find flaws in the design and parts that wouldn't be able to be manufactured, so I had to split parts so that it would be able to. I then worked on making ribs in the internal part so it would be able to hold the battery in place. I also made the CAD insert for these parts to prove that it was feasible to actually make. I looked into thermosets and thermoplastics as well as creating a rubber seal to make the part watertight, while also continuing with snap fits and other to make sure the seal was tight and waterproof. This is where I also started thinking about induction charging, as I didn't want elements to be open and I didn't want electronics to be wet. I spent a lot of time looking at induction charging and discovered that I could charge the battery and then use the battery to heat the cooker, using electromagnetic waves generated by electromagnets and copper coils. I then went on to design the shape of the coil and decided that I'd stick with the rounded shape as it was more feasible to actually work. Originally I thought I would just heat up a copper coil that would get warm, but in fact you have to use a ferrous metal like iron instead, which absorbs the electromagnetic current and gets hot. I then realised I'd have to insulate it with aerogel. Cast iron pots are used for induction cookers anyway, so I thought it would be a suitable material, but I used CES to prove that it would be. For the cover for the heating element I would use glass ceramic, as it's easy to clean and it can get very hot without damaging. On the right hand side I've created a sectional view which has all the parts that I've made so far in SolidWorks. This includes snap fits and a rubber seal to keep it all waterproof. I decided to have an internal surface in the silicone to improve the insulation of the main body because it needs to trap heat to be able to cook the food. I then looked into the possibility of not actually having buttons on the product but instead just using power transfer by touch. I decided to use polypropylene as my main material as it's very versatile and also easily recycled. I also decided to make the top bit wider because it wouldn't be able to fit someone's mouth if they needed to use it. Here I've drawn the top of the lid and potential ways to attach it to the top clip of the body. Drawings on the right were just references I used for CAD while making it. Here I wanted to develop a colour scheme, so I used pre-existing Philips branding and tried to make details and designs to help influence my own product. Here I looked at symbols that I could have potentially on my product which would be similar to pre-existing Philips products. The flame then developed on and became the logo for my product. I used the intangible and tangible aspects of Philips that we learnt from semester 1 to make sure that my product was similar to Philips in that way. I also then developed the logo as well as giving my product a name. I came up with core because of like a molten core which represents a trapped heat, just like my product. I began doing keyshot renders of my product as well and decided an all black theme with an LED strip that would change colour as feedback to the client or user that is using the product. This is my keyshot render with all the materials that I would use listed. On the right I use Philips branding to decide how to lay out my presentation boards. Here I look at potential sailing photos that I could incorporate my keyshot into for the development boards. Silicone would be one of the only parts of my product that wouldn't actually be able to be recycled. Here I looked at potential foods that you could put into the product. And then I worked out the price, which took quite a long time, but in the end I worked out that it cost £20 for all the materials and on average about £60 for manufacture and labour costs. Thank you.